Hi kids, now we'll be looking into this question from your revision package. Anyway, you can read the question. The question says like there is some liquid poured onto flat glass surface which does not wet and it spreads out into a pool of uniform thickness regardless the size of the pool. The thickness is. So basically I'll be solving without values. So the pool is going to look like this. This is the general figure like mentioning that surface contact angle. Now, this is how the pool is going to look like. Now when I draw this figure, it is going to look like this. I mean I can't draw obviously this figure, so I have drawn it in my own way. Right? So when you look from this side, the figure is going to look like this. Now I'll be drawing the free body diagram of slice. So I'll be slicing it. So I'll be taking a slice. I'll be taking a slice like this, and I'll be drawing the free body diagram of that. This slice and this slice, this length into the page it is dl. Into the page it is dl. Now if I draw the free body diagram where this length is dl, then there will be, this is surface. So there will be surface tension force T into dl. There will be surface tension force T into dl. Now pressure when you go down, it will keep increasing. So if you want to find the force on this side, then it is average pressure into area. This height is h and this length is dl. So area is h into dl. Now pressure force from this side is going to be pressure into effective area. Effective area is again h into dl. So anyway, I'm not bothered about vertical forces. There are various reasons why vertical forces will be in equilibrium. I want to make horizontal forces to be 0. If I make net horizontal force 0, then P naught into HDL will get cancelled. So rho g h square by 2 into dl will be equals to TDL minus TDL cos theta. From here we will be getting height is this much. Right? Now the same thing we can try to do it in a slightly different way, but before doing that you should be aware of this relation. Wherever there is there will be interface, there will be surface tension. Now surface tension force because of the interface air and solid. Surface tension force because of the interface liquid and solid. Surface tension force because of the interface air and liquid. Now the relation between them will be given by this, which I am not much bothered to derive it right now. So you take it for granted, and probably will be using this thing also. When under the action of any forces, a system of particles is in equilibrium, then this system receives or is imagined to receive any small disturbance. The total amount of work done by all the forces acting on the various particles is 0. That should intuitively make sense. Anyway, you can read by yourself and you can try to understand. In other words, potential energy of the system should be minimum. That also you people are aware. We shall now apply this principle. Okay, so that's called as principle of virtual work. When it is in equilibrium, then small work done, at least imaginary work done because of all those forces will be 0, or the other way of saying it is potential energy should be minimum. Yes, so now I'll be talking about energy. Total energy, potential energy has to be minimum. Potential energy here will be because of this thing. This is liquid and air interface. So surface energy is going to be surface tension between liquid and air interface into area. This area is approximately pi r square. Now similarly this area is approximately pi r square. So surface energy will be surface tension between solid and liquid into pi r square. Now apart from that, the remaining area, so let me say the total area of the plate is capital A. Then the remaining area is going to be capital A minus pi r square. So the remaining area consists of like solid and air. Surface tension between solid and air interface into area available there. Now this is the surface energy because of liquid and air. This is the surface energy because of solid and liquid. This is the surface energy because of solid and air. Now apart from that, gravitational potential energy mg, center of mass will be at h by 2. Density into volume, mass into g into h by 2, mg h by 2. This is capital H I have written anyway. Right, potential energy should be minimum. Now it looks like there are many variables, so I am converting it into a simple thing which is h. Volume, given fixed volume, so I can write this as volume by h. This is volume. So when I rewrite it, I'll be reading of this format. I am expanding it. But look here, this is TSL minus TSA into V by H. TSL minus TSA. Now TSL minus TSA. TSL minus TSA is minus SLA cos theta. So this is minus TLA cos theta. When I substitute it back, I'll be getting single variable thing which is h. So if potential energy has to be minimum, its first differentiation, variable is h, its first differentiation has to be 0. When I differentiate it with respect to h and make it equals to 0, I'll be getting the same result, right? Now you can extend this and you can derive some of the results which you already know. So you can derive excess pressure inside soap bubble. Excess pressure inside soap bubble. So surface area is going to be 4 pi r square, but 2 interfaces will be there. So 2 times of 4 pi r square will be surface area, and volume is 4 by 3 pi r cube. Now if potential energy is minimum, then small change in it has to be 0, right? So du has to be 0. So or you can say work done has to be 0. If you are taking work done, here you will be getting positive symbol, here you will be getting negative symbol. If you are talking in terms of potential energy, then you will be getting negative symbol here and positive symbol here. This is work. This is the loss in pressure energy kind of thing. If you put positive here, then it is work done because of pressure. If you put positive, it is increment in surface energy. If you put negative, work done by surface tension. So if you put negative here, then work done by surface tension. If you put positive here, work done by pressure force, that should be 0 for small imaginary displacement. If you make that one to be 0, then you will get pressure difference is 4T by R. What is that T? The T is between liquid and air. Right. So this is the formal derivation with force method, which you people will be already knowing. Now apart from this, you can do capillary rise also. Capillary rise. Now again, I didn't draw the figure, but if it was initially settled at some height, if you want to increase the height by small amount, then solid and liquid area will increase by this much amount. So energy will increase by this much amount. Similarly, solid and air will be reduced by this much amount. Now apart from that, some liquid will go from the beakers, like top layer, to the meniscus part. So MGH, right? So that's increment in potential energy. Increment in solid liquid interface energy, decrement in solid air interface energy, and increment in gravitational potential energy. That is the small change, right? But that has to be 0. When I make that thing to 0, now TSL minus TSA is again coming into picture. So I am converting it into TLA cos theta based on the 10 CRT thing, right? So I will be converting. From here I will be ending up getting the same result what we will be getting by force method, right? And probably I will be attaching the PDF. If you want, you can read more on that, and you can do the same thing for 2 plates also, but at an angle theta. But the derivation what I have done, which I have, is when contact angle was 0. So you can look into the PDF, right? Thank you.